olarak çözüm ortaklığını yaptığımız firmaların ürün ve hizmetleriyle beraber sektöre hizmet veriyoruz ve bunlardan birisi olan DDC ile birlikte burada bir sunum gerçekleştireceğiz. DDC, savunma sanayi ve sektör tarafından aslında çok yakından tanınan bir firma. DDC'nin ürün ve çözümleri özellikle database konusunda ağırlıklı olmak üzere, bunun dışında da işte güç kaynağı ve güç çözümleri ve işte motor kontrolcü ve benzeri birçok çözümleri de hizmet vermekte. Bunlarla alakalı bir bilgilendirmede bulunmak istedik sizlere. Yeni teknolojiler DDC'nin sağladığı özellikle güvenli, sağlam ve güvenliğin dışında ayrıyetten firmaların, yani DDC'nin yine aynı şekilde bilinirliği, sağlam ve güvenilir olması da bu işte çok fayda sağlıyor bizlere. Bunlarla alakalı genel bir bilgi vereceğiz. Dinlediğiniz için şimdiden teşekkür ediyorum. Bu şekilde de ben ilgili arkadaşı sahneye davet edeceğim, Fabian Bey'i. Fabian Bey. Kendisi şunu gerçekleştirecek.
So, thank you very much for that nice introduction. As Seyfettin mentioned already, I'm Fabian Lange, I'm the channel manager for DDC and responsible for the Turkish market. And I just want to give you a short overview, first of all on DDC as a company, and as well on our SSPC, Solid State Power Control Solutions. So Data Device Corporation has a long history. We were established in 1964 already, and that shows we have a long history in the products and the solutions we are providing to the industry. We have manufacturing operations all over the world, in New York, in San Diego, UK and Mexico. We are around 700 employees worldwide, so a small company, but acting worldwide. And just a slide on our design capabilities. As Seyfettin mentioned, we are not only doing solid-state power controllers, we also do mil standard 5053 communication interfaces. And we use multiple form factors, custom form factors. We can do rugged, lab-grade box solutions as well. It's all our in-house IP, which enables us to do customization where it's needed. And we support all major operating systems, mostly for our data bus solutions, but also for some other projects and systems we are providing. DDC is a trusted source, so we have a long history in the military industry, so we know about life cycles and we know how important it is to the military industry that products and vendors support their products for a long, long time. So we take care of all the life cycle management of our products, which includes the obsolescence management. So DDC is taking all the approaches to make our products available as long as possible. We use advanced components, custom ASIC, plastic encapsulated multi-chip modules, and we have a mill-proof hybrid manufacturing line in New York where we can provide hybrid solutions to the industry. As I mentioned before, board as well as box level assemblies, so we can do both actually. We provide solutions in board form factors, common form factors, as well as custom form factors, but also do any kind of box solutions and encasings for different kinds of application. Products are qualified and tested in-house in DDC to various test and environments, EMI, vibration, shock, humidity, everything that is needed to prove that our products are reliable in the field. And last, and maybe the important point also for the Turkish market, all of our products are ITAR free. So none of our products is controlled by ITAR. All of our products are mostly standard off-the-shelf products and only controlled by the Department of Commerce. So it's EAR 99. which is very important because it doesn't block us from exporting our products into the world and also to Turkey. The only thing what we might ask for is an end-use statement information. So what we need is for our records where these products are going to be used. Qualifications, of course, if you act in this market, military as well as in the aviation industry, you need to have various kind of certifications. So DDC holds all of the needed certifications for this industry. And then showing you the product overview of DDC. This is just to give you an idea of what other kind of solutions DDC is providing. We have solutions in the connectivity area, which includes all kind of data bus solutions, let's say for military applications. We provide MIL standard 5053 solutions ranging from small components, ASIC components, through small form factor cards to various embedded form factors and test cards up to complete system solutions. So we provide, for example, a complete avionic computer system, embedded, rugged computer system. The next product area is power and control. So we provide custom power supplies for all kinds of applications, ranging from maritime via land applications into the airborne applications for military as well as civil aviation. Our smart power controllers, what this basically presentation is all about, and our transformer and magnetic solutions. So we built all of our transformers for the data bus standards, for example, for Ethernet, MIL standard 5053, you need transformer solutions. We built all that in-house, but also doing custom transformer solutions, power transformer solutions, various kinds of magnetics. The last product area is motion control, which consists of our motor drives and controllers, also used widely in any kind of land-based and ground-based vehicle application, and our motion feedback devices. These devices are used everywhere where you have a turning application, let's say a radar, where you need to sense the angular position and actually transfer it into a digital signal. Now moving over to our solid-state power control solution. So a technology comparison, because solid-state power controllers is basically replacing mechanical circuit breakers. What you know from your home maybe, the mechanical circuit breakers. This is also in any kind of land-based application as well as in air-based applications, they use mechanical circuit breakers. And we replace them with solid-state power controllers, so an electronical device. What brings that in sense of the benefit? So in sense of reliability, a solid-state power controller is 25 times better or improved in sense of the MTBF compared to a common mechanical circuit breaker. These devices are not vibration sensitive because there are no moving parts inside, so very important for land-based applications where you have a harsh environment, you have a lot of vibrations, you have shock, where circuit breakers could fail. Solid-state power controllers are not affected by this. You have reduced EMI because we control the switching times, switch on as well as switch off, what you cannot do with a mechanical breaker. Reduced swap, so 7 times power volume density. So the SSPC is 7 times better. If you compare, let's say, 16 common mechanical circuit breakers to one of our cards, which is shown in the right top corner, that's a 16-channel card replacing 16 mechanical circuit breakers. 5 times better in sense of power and weight density. So this 16-channel card is much lighter than the common mechanical circuit breakers. Also, the safety aspect. It's significantly faster in sense of fault clearance. Also significantly faster in the reaction time if a channel needs to be tripped or open. It's faster than a mechanical circuit breakers, and it has a more accurate load monitoring, what you basically can hardly achieve with a mechanical circuit breaker. You can do it with an electronic device quite easily, and to monitor the load, so the current, voltage, temperature of your load, in order to determine the health of your load with the solid-state power controller. It's just a short slide on the functionality. Basically, it's an electronic switch where we control the switch on and switch off time. It's all based on in firmware on the card itself, and this firmware controls the behavior of that switch. So you can use it as a breaker, as a safety device, as well as a controllable switch in the system. And what problems are we solving with these SSPC solutions? So it's more reliable, as I explained before, because it's a solid-state implementation compared to mechanical parts, moving parts that could fail much faster than an electronic part. A faster fault clearance, as I explained before, size, weight, and power enhancement over the mechanical circuit breakers, and you have a better control, measurement, and reconfigurability over your device. So if you're using a standard mechanical breaker, you have to choose the current rating before you design your system. With one of these SSPC cards, basically, you can program it by software. So these channels have fixed current ratings, which you can adjust by software according to the loads behind it that needs to be protected. For example, a 25 amp channel can be programmed down to 2.5 amp, so you can adjust the channel afterwards to the needs of your system. And this also gets the system, let's say, ready for the future. If you connect a new load to the solid-state power controller, you have the ability to program the current limit of that single channel, again by software. Hidden cost benefits, as I explained: improvement over mechanical circuit breakers and relays, reduced inventory because you need basically one card to replace 16 standard circuit breakers, standard configurable card modules, as I said and explained before. You can program the channels according to the needs in the system. Parallel channels in order to get to higher channel ratings. So on our cards it's possible to use, for example, 2 10 amp channels and parallel and group them together to get to a 20 amp channel. So this is very, let's say, configurable on the user level to be able to customize it for any kind of application. There's no need for scheduled contact replacement because, you know, solid-state power controllers and electronic equipment, there is no mechanical movement in these parts. Current monitoring allows load trend and health analysis. I explained that before. With monitoring the current, the voltage flow through that channel, you can calculate already the health of your system you're protecting behind it. Optimized cable selection, tighter trip tolerances allow the cables to be reduced. Cable lengths can be actually reduced because there's no need for a centralized circuit breaker panel anymore. You can put this card basically anywhere it fits into a vehicle, and you can control it via a CAN interface or a serial interface from a computer or a touch panel. And there's no need for a centralized circuit breaker panel anymore. So this saves a lot of costs and time in sense of developing the system. And what I would like to show you is our history in that technology. So we started back in the 1980s already with replacing circuit breakers on ground vehicles, just replacing a single circuit breaker via a one-channel SSPC module. And we evolved that over the time into various card products ranging to boxed solutions for harsh environments, for rugged applications, and just lately moved into also flying applications into the military as well as into the civil aviation market. So we have a long heritage with these devices. We have more than 800,000 of these channels installed currently on military ground vehicles worldwide. And I will give you some examples on which vehicles are using DDC solid-state power controllers just in a minute. The last slide as an overview on our card and module offering. As I said, it's ranging from card products, from 1-channel, 2-channel cards up to 32 independent channels on a single card. 115 volt AC, 270 volt DC cards, mainly 28 volt. Most of our products are 28 volt. Configurations with up to 400 amp, controlled on a single card. So these are mainly used in primary power distribution, let's say for a turret application which needs a lot of power, a lot of current flow. We can control this with one of our SSPC cards. So that, and that is the overview. I structured it into, the different kinds of ground vehicles, starting with light tactical vehicles, where you, let's say, connect some mission power, some control and command interfaces, which you want to actually protect and control via a centralized solid-state power controllers. As I said before, this saves you a lot of weight in these small vehicles, a lot of size, because you don't need these circuit breakers anymore. You connect an intelligent touch panel to the card itself, and you can control your loads from that touch panel. That's what we did, for example, on the Humvee vehicle. They included some command and control equipment into this vehicle. And they use one of our cards together with a customized touch panel to control the loads and protect the loads on this vehicle. Going to tactical vehicles, you already have more loads, so you would need more circuit breakers. So you have various kinds of mission equipment, antennas, radars. You have weapon stations in these vehicles, radios for communication. And for some examples, the MREP, for example, is using DDC's solid-state power controllers to control all the loads in the back of the vehicle. So that includes the weapon station, it includes the communication equipment, and all is controlled by 1 or 2 cards depending on the configuration, and controlled by these 2 cards, replacing the complete the mechanical circuit breakers. And this is used in 12,000 vehicles at the moment, MRAP. LPPV Foxhound, again, they had to control the mission equipment in the vehicle. Again, communication equipment, radios, antennas, weapon stations, and they wanted a rugged enclosure for it. Basically, this device from DDC, what you see here, the box solution, is sitting in the entranceway of the vehicle. So soldiers step on it when they get into the vehicle, and it's a very, very rugged design, and it survives. So they're very happy with it, and they use it in over 400 vehicles, this box solution. Going to JLTV, a big program in the US. Again, they're controlling the weapon stations, the radios, the mission equipment, all they need in the back of this vehicle via modules from DDC. And these are 50,000 plus vehicles using DDC's solid-state power controllers in a harsh and rugged environment. Going to the fighting vehicles, so there we get also into turret applications, into primary as well as into secondary power control. As I said before, we have cards controlling up to 400 amps on a single card, so this is mainly used in the turret application. For the rest of the vehicle, they use lower rated cards to control the various systems and equipment they have installed on these vehicles. So this is the Bradley, actually also where we started to replace the mechanical circuit breakers with these single modules. And with the various upgrades, they're still using DDC's products in these vehicles. AMPV, another vehicle where you need to control the loads in the back. So you have, for example, medical equipment in some of the configurations. So they control, again, these loads by the solid-state power control cards by DDC. Last but not least, for an example for a fighting vehicle, the Striker, a US design. We are basically on both. We are on the vehicle as well as on the turret, which is provided by Kongsberg in Norway. So the turret manufacturer is using one of our cards to control the various applications and systems in the turret, as well as the vehicle itself, the Striker vehicle, is using our cards for primary and for secondary power distribution. So you see we have the 2-channel 150 amp that gets to a 300 amp solution, which can be controlled by a single card, and then 16-channel cards which control the various other loads which do not need that much power. That was the short overview. If you have any questions, I would like to open up the session for that. Yes, please.
Burak Ruder from MSI Turkish Defense Review. You gave examples about usage in the United States and Europe. Are there any of your systems on Turkish vehicles currently?
We don't have it at the moment, but we are talking to the industry here. In the opening sessions yesterday, we heard about the percentage of own development. Turkish companies are not required but encouraged to do on these systems. And with that being a complete solution, it is I'm not saying difficult, but it's not as easy, I would say. But as I said, we can export to Turkey. We can provide these solutions to anybody that is interested in.
And the second question, from customer's point of view, in the whole life cycle, what is the benefit of your SSPC solution when you compare to total life cycle cost? Can you give a percentage or any other figure?
You possibly have to compare it against the mechanical breakers. As I said, mechanical moving parts, so you need to take care before actually they fail. You need to replace them. A solid-state power controller, actually with no moving parts, there's no need for replacement before they, in the unlikely event that it is failing. But with all the cards and boxes we have installed, we never encountered any failure, any solid-state power channel or power card failing actually. So you have to compare it against the mechanical breakers, and there you get a huge benefit in the sense of the maintenance cost. Also, if you need to, let's say, accommodate it to new systems, which you implement into a vehicle, let's say, you don't have to replace a breaker or you don't have to add an additional breaker. You just use another channel on the card which is already installed in the vehicle and program it according to the application. So I mentioned some numbers in the front. In sense of the MTBF, mean time before failure, the SSPC card is 25 times better than a mechanical breaker.
Thank you.
Bir sorumuz daha var.
Ahmet Yürekli, retired colonel from Turkish Army. I have some questions about, actually you are producing solid state circuit breakers, as far as I understand. But, and also you are talking about 400 amperes, which can be, what about the heating in the control, you know, or do you know about the, like, we have Leopard tank or M60, A3 or T types of tanks, and we have to use, we are using actual circuit breakers.
Mhm.
But what about the you are saying that solid state circuit breaker is more advantageous than the other,
Right.
mechanical. But we are talking about the 400 amperes, you know, heating problems.
Exactly, and you mentioned a very important point. I don't have the exact numbers for all of our cards, but looking at the 16-channel card, which is a very common used card in the military industry, the power dissipation on that whole card, controlling up to 86 amps on the whole card, it's 30 watt. 30 watt is the power dissipation on that whole card. So there's not that much heat involved which you need to dissipate actually. Compared to a breaker, they're much better in sense of the heating and the temperature you need to get away from the card. As I said, the total power dissipation of a 16-channel card controlling 180 watts, 180 amps is 30 watts in total. That's it.
Yeah, you mean if you consider the, like, part by part, like maybe 10 ampere or less than 10 amperes, huh? Amps.
You mean for 10 amp channel?
We have, because you are controlling many cards.
Right.
Power distribution, you know. So you mean that it's not the 400 amps or 106 amps. Am I right, or am I considering?
I don't know if I understood your question correctly. So what I'm saying is these cards are capable in controlling a maximum of current flowing through this card. And we made sure with our design that we can safely handle that current on the card. It is a very difficult design in sense of the board level to dissipate the heat evenly.
If something goes wrong, who's gonna replace the card? We have to have like spare parts.
Correct.
Yeah, if something goes wrong.
Correct, but
yeah, but
this is
if there are sanctions, you know, like
right.
sanctions that you are applying to Iran or
right. Of course, you will have some spare parts
yeah.
For replacements if something is broken, but it's very unlikely that one of these power MOSFETs is failing on the card. We never had a power MOSFET failing on one of these cards. It's sometimes the communication interface that is broken, so it's an FPGA, it's a microcontroller solution. That is more likely to break than the circuit breaker, the MOSFET itself. So you have some spares, but you don't have to have that many in stock, for example, comparing it to mechanical breakers. Because for mechanical breakers, you need to replace them by certain times because of the mechanical parts. These cards, we can give you the MTBF figure, and I already said it's 25 times better. So at least 25 times better in sense of the replacement of the card to make sure the system is still safe.
You mean that you are giving a guarantee for life cycle failure?
Yes.
Thank you.
All right. Thanks a lot for your fruitful presentation.
Thank you very much. Thank you.
Thank you. Değerli katılımcılar, bir çay kahve molamız var. Molayı mütakip saat 15:20'de salonda oturum için hazır olacağız. Ve 2 oturum sonra kapanış yapacağız. Bilgilerinize sunuyorum.
Daha güzel anlatırdın da. Ulaşılmazlık ama çok değil mi? Şu Sistemleri markasını yapıyoruz. Son kullanıcıya direkt çözümlüyorsun. Karaya bakıyorlar. Karaya buyuruyor. Deniz şartları çok daha iyi olmuyor.
Evet, doğrudur. Doğrudur. Ekranları açıyorum ama buyurun. Buyurun. Yine dediğimiz gibi. Güzel olur ya. Güzel yok.
Sadece yani ayrıntısını sadece yazımcılarımız. Ben bir şey düşünüyorum.
Coğrafya durumsal farkındalık üzerinden 3 boyutlu dünyayı kendine sevmiyorlar anladığım kadarıyla.
Yani coğrafya sistemi demekten sonra coğrafya durumsal farkındalık
Doğru,
yaratmak şansını yaşarız.
hesaba kadar suyun aksiyonu Allah her yerde.
Şeyi katılabilir misin?
Oradan yazılıma geçiyorsun değil mi? Hayalet yapayım diyor. Benim arkadaşım baba hayalet diyor, hayalini biraz...
Bana öyle de demiyoruz yani. Siz hayal ediyorsunuz. Biz yaptıklarımızda o hayalimizde çok rahat bir
Şey kaçırsa sizde mi? Tamam ben hemen gitmem. Şöyle bak, çakarsın isterseniz olur. Ben burada bekliyorum. Nasıl isterseniz daha önceden ben vaktimde gidip anonsa gidip başlarım. Fırsatı bulursa bir hafta içerisinde uğrarım. Telefon eder uğrarım. Size su altı dünyasının yazılım ihtiyaçları hakkında